Okay, so we solved for I of t. Now let's solve for E of r, E of t, I'm sorry, E of L, where the hell's that? And E of C, voltage drop across each of those, because we still have to do that. So E of R equals I times R. I feel like E of R equals I times R. So E equals I times R. I feel like I've heard that somewhere else before. So what is I?
It's
0.365.
365 times R, which is
500.
500. So E of R equals, so E of R equals 0.365. What'd you get? 182.5? 182.5 volts. Well, how about E of L? So E of L equals I times X of L, which is the equivalent of the R. So E of L equals 0.365 times, what was it, 1319?
Yeah.
1319.47. So E of L equals 481.6 volts. And then we will solve for E of C, which equals I times X of C. So E of C equals 0.365 times, was it 220 something? Yeah, 221.05. So E of C equals 80.683 volts.
So on E of L, 481 volts. That's out of 440 volts.
That is out of 440 volts. So 481.6 plus 182.5 plus 80.683 equals 440, right?
No.
So what happened to Kirchhoff's laws here?
Went out the window.
Out the door. Why? Because of phase shift. That's your best answer. All right, so next we solve for power. Solve for power. So we'll do power true equals I squared times R. So power true equals 0.365 squared times 500. So power true is going to equal 66.6 watts.
Devil's power draw.
All right, next is power apparent. Which is expressed in volt amps, which equals volts times amps. It is I squared times Z. So power apparent equals I squared 0.365 times Z, which was 1206.87. So power apparent equals 160.79 volt amps. And then power factor. Am I going too fast?
Yes.
Okay.
I kind of, if you don't mind, would like to go through the, I guess they call them the prefixes, what they're expressed in, because sometimes I'm a little lost. I have them written down, but it's kind of got to like shift through all my notes to like
It's not easy to
No,
remember all
there's
this
a lot
little
of
stuff.
new letters out there that are like, this is expressing this, and this is F, and this is I, and this is P.
Do your best on the test. I'm pretty lenient on this one. Especially as long as you're at least getting the volts or amps. So I'm at least getting that you're sort of in the right category. If I'm asking for amps and you put watts, that's another thing. But if I'm asking for power apparent and you put 160.9 watts, I'd probably look the other way. I'd be like, you got the idea. All right, power apparent. So we've got power true. Now we have power apparent. So the next thing we want to do is power factor. Power factor, which is power true over power apparent. So the power factor equals 66.6 divided by 160.79. So our power factor equals 0.414. And so anything close to 0 is
Purely reactive.
reactive. And 1 is,
Purely resistive.
so this is closer to reactive, in the middle, but closer to reactive is what I would say.
So it'll be less efficient.
Yes. And we have not done phase angle yet, have we?
I thought we did.
Phase
Yes,
angle?
yes,
Yes.
yes.
Did we? Okay. What did we get?
65.53. So yeah, I'd say it's more.
65.5. All right. So one more time, let's do this. Let me see. There we go.
Oh my gosh.
Okay. So 1. Solve for what? What'd you solve first? X of L. 2. X of C. 3. I don't have to read solve for each time. So then we did xt, right? All right, number 4. Z. Maybe I should put the formula here for X of L is equals 2 pi frequency times the Henrys. X of C equals 1 over 2 pi frequency capacitance. X of T equals X of L minus X of C. Z equals the square root of X total squared plus R squared. 5. I. So I total, which is E divided by Z. 6. Scroll up like that. You mean down? He's not ready. He's not ready. We okay? This is actually the way I have it in my notes, so I was just going by. So we could do phase angle there. We'll go E of R equals I times R. Steps number 7. E of L. I times X of L. Number 8, E of C equals I times X of C.
E of C? Or X?
Hmm?
It's tired, I'm late.
E of C equals I times.
Oops,
X.
I'm sorry.
It's tired, I'm late.
It's late. Next.
P power total.
Okay, not power total.
Power true. True power. Oh yeah.
Power.
Power true equals
X of T times
I squared
I squared.
times R.
Okay. I squared. Where did it say
And that is going to be in watts.
Oh yeah.
10.
Power apparent.
Power apparent. I squared times Z, and that is going to be expressed in
Volt amps.
volt amps. 11.
Power ratio.
Power factor.
Power factor. Which is power true divided by power apparent, where 1 equals resistive and 0 equals reactive.
So whichever number is closest to is the answer, resistive or reactive? Like 0.414 is more reactive?
More reactive, but I would say, oh, it's just reactive. I'd say it's more reactive. It's just a way of looking at it. 12, which we didn't do in this order. Phase angle. Which would be sine minus 1, cosine minus 1, or tan minus 1, where this equals opposite over adjacent. This is adjacent,
Over hypotenuse.
opposite. Oh, yeah. No, looking at the notes. Sine, opposite over hypotenuse. OPP over HYP. Cosine. Got that one right. Adjacent over hypotenuse. And tangent, opposite over adjacent. And lastly, is it inductive, capacitive, or resistive? What's that more of? All right, got it? Okay.
Was that the previous example that you did, was that more?
Actually, let's just get rid of resistive because I think it's more of a, is it more inductive or capacitive? I don't want to confuse anybody.
Going with that power factor part.
Mhm. No, you're going with the X of T.
Okay.
X of T. In Canvas, I posted a thing that looks like this. It's in there. It is AC series practice problems. And so there's 10 practice problems. We've actually just did number 1. So you can go in there, practice it. The answers are in there. Check yourself against those answers. We have time for one more if you want to do one more.
We do a little bit slower. I don't know if you mind, if you guys people mind. I don't know how long that took, but
Yeah, I could have gone with
it's a lot to think about.
do it again. I want to watch.
Finish the salt.
I mean, I want to get it. I kind of get it. It's just this hella formula.
I'm just thinking the longer we sit here and talk about how long I should take, the less time we're gonna have, so.
Start drawing it then.
Hurry up.
That was rude. No, it's, hey, take it slow.
Oh, hurry up.
Get to drawing, Teach, let's go.
Didn't know you got an F on your Magneto, man. Damn.
Is that what that is?
I was trying to. I was being in a hurry.
If I didn't act like
Hurry
that,
up and
I would
wait.
survive the rest of my life.
A lot of sixes here.
Scary number. 8 versus.
Okay, you've got all the notes now with all the steps. So step one.
Solve for x of L.
Step one is x of L.
So, 1,105.8.
So I thought you said you wanted to go nice and slow.
Oh, sorry. I think we were doing this together. I don't know. I was.
Kind of.
I got a
Sorry.
Wait
different
for everybody to get
What
it.
do you have?
I got 1,256.
Yeah.
Oh.
What did you do?
Well, that's why.
You're moving too
That's
fast,
why I
that's
said out
why.
loud to check my answers. I wanted you guys to give me feedback.
Your feedback is your wrong.
Is my what?
Feedback is your wrong.
I'm wrong.
I fucked up, you guys. I fucked up. You screwed up, boy.
Are you sure?
No.
What'd you do?
I did it right.
2 times 5.
Times 2 times pi times 22.
22.
22 hertz, no?
25.
Oh, 25. I wrote a fucking 2 down. That's why.
Nice.
My problem is.
Freaking.
Damn. Okay.
Did everybody get x of L okay?
Everyone.
Okay, moving on.
Problem.
X of C equals 1 over 2 pi f c. So x of C equals 1 over 2 pi times the frequency is 25 times the capacitance, which is 50 microfarad. It's 50 times 10 to the negative 6.
Alright, somebody's gonna give me the answer so I see if I did this right or not.
127.
Yeah, cool, I did it. I didn't want to say my answer so I didn't feel all embarrassed.
0.127, right?
No, what?
Oops.
127.
127. What did I get wrong here?
Did you
2 times pi times 25 times 50 micro.
put it in
Ah,
parentheses?
I don't know what I did wrong, but
Maybe you didn't put it in parentheses.
no, I didn't put in parentheses either time. Don't need to. 127.32. Did everybody get x of c?
Yes.
Looking around. What's next?
X of T.
Hey. X of L minus XC. So X total equals 1256.64 minus 127.32.
1,000. 1129.32.
That?
Yes.
Good.
So that tells us that that's more inductive.
Yes.
Back here, we look at these two. It's more inductive. 1256 is bigger than 127. What is next? Everybody got
Solve for
XT?
Z.
Yep, solve for Z.
Z. Z equals the square root of xt squared plus r squared. Is it 60? 60 ohms.
What is Z measured in? Is that ohms?
Yes.
Okay.
Everybody got Z? What comes after Z?
I total.
I total. What's our formula for I total?
E over Z.
So easy.
Everybody get I total? Yeah, okay. What's next?
E of R.
E of R equals I times R, because it's like E equals I times R. So E 0.584 times 60.
35.01.
All right, take your word for it.
What was that?
I took your word for it. No, I'm not going to take your word for it. 0.5. Oops.
I don't have an E of L and E of C. I don't know what to get. I don't know why I write that down. Was it supposed to be on there? I have a formula for E of L and E of C.
All right, what's next after E of R?
E of L.
E of L equals
Oh,
Well, I wanted to put the formula.
Oh, 0.584 times 1,256.
Well, it's I times x of L, I times x of L. So E of L equals 0.584 times x of L. What's x of L?
1256.64.
Here we go. So E of L equals.
733.88.
Anybody disagree?
Nope.
Next.
And then in volts?
No. Yes. No. Yeah. I think technically if you're putting E of R equals, you don't have to put volts because it's redundant. You just said it's E of R.
But somebody might get confused, so always treat them like they don't know any better.
That's right. Equals I times x of C. So E of C equals 0.584 times, what's x of C?
127.32.
So E of C equals
74.35.
74.35.
Yes.
Next. Yes.
How did you get 74.35?
I times x of c.
5.584 times 127.32. Power true. I squared times R, so PT equals 0.584 squared times the resistance, which is 60.
Watts.
20.46
Watts.
watts. Power apparent. I squared times Z.
So 584 squared times 1130.9.
Yes. Yes.
385.70 volt amps.
What'd you get?
385.7 volt amps.
Good, I got the same thing. Next is the
Power factor.
Small. Damn, it really makes a difference. I don't know if it's a big difference, but I was rounding to the tens place. Just
it starts to make a big
it
difference.
starts to make a big difference.
Yep.
Yeah, I mean, getting them all like really close, but that one I was 5 off. I got 380.4. But I mean, at least I know I'm doing it right.
Yeah.
Yeah.
So then we get 20.46 divided by 385.7.
What would you say? What place would you stop? Would you round to then?
2 or 3 every time. I've been doing 2 here.
Okay.
Oops. 20.46. And what do we get?
0.05.
I got the same power factor.
0.053. Is that good or bad?
Bad.
Very reactive.
Okay.
Very reactive.
Very reactive.
We're gonna find more.
And what
Phase angle.
phase angle?
So that's I forgot how to do that
Okay.
with your. I know the formula, but I don't know
Well, it's just
the, which ones are like the numbers you.
So like for 10, you do the ZT.
Just draw the
or
triangle.
XT.
Wow. Draw the triangle.
All right, we had 60 here.
Yeah, I get that.
We had
So Z is here.
113.0.9.
And then this is resistance.
And-
X. X total. Okay. Okay.
Is that correct?
Yeah, for sure. Okay.
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 Just do your fun little
Totally.
Sin 10 code.
That's what I didn't know. I didn't know which ones to input. And then it's.
Yeah.
I just heard 16.
That's kind of a triangle that really looks more like this.
Yeah.
6.96.
Oh, it's the Washington.
It's this angle right there. All right, everybody got that?
And it is
All right.
very much.
Okay, again, practice stuff is in
Canvas.
Canvas. All right, so for tomorrow, what formulas do you wish to see up here on the board?
Area of a
And this is all the room you get. You can't be scrolling.
area of a cylinder.
Yeah, X of L, X of C.
Well, you got to tell me what to write.
Like right now?
Okay.
Yeah.
X of L, 2 pi.
X of L equals.
Oh my god. Alright. That's it. That's all I need right there.
Like, yeah, can we just do all these?
That's what I'm gonna say. Yeah, Ohm's law, please.
Ohm's law?
2 pi F.
Can you see that okay?
Yep.
1/2 pi FC.
Okay.
XT. Actually,
We're asking every kid.
No,
I want everyone. Don't put
No, I
XT
put
on
them
it.
all up there. I'm like-
What?
He's going, you guys are really asking for XT. Don't put it on this.
Yeah, he doesn't get to see it.
Put sine, cosine, and
Yeah,
tan.
phase angle.
Yeah, phase
Okay.
angle, so sine
What-
sine minus 1 equals opposite over
What do you
hypotenuse.
want right next? Me to write next.
Z, okay, Z, alright. They got better ideas.
Do you want this formula right here where it's
Yes.
X squared, XT squared.
Wow, I feel like getting
You
cheap.
can see that okay?
Oh, yeah.
Okay, if you need me to write it bigger, let me know.
IFT.
Equals? Okay, is there a spot where I can no longer write because you guys can't see it? Is that?
We'll tell you when.
Okay.
Will we let us stand up during the test?
Yeah. What else?
E bar.
I times R.
Okay.
E of L.
Suppose you want E of C too.
Yeah.
Instruction is unclear. I put
Power true.
formula for X and L after
I squared times R.
Power parent I square Z.
Yes.
P true.
And then, can we get our sine, cosine thing?
Yep. So let me see. Sine minus 1 is?
I thought he was gonna leave it as sine minus 1.
You weren't specific.
Jason over hypotenuse.
Opposite.
RMS up there.
Yeah, on the
Can you
power
fix
tree.
your C's a little bit on the?
I tried very hard to do that, but it's not. Which C are you worried about?
The EL and C are kind
I,
of L's look like.
Either way.
I don't know.
Either
Yeah,
way,
look
it's the
above it.
same equation.
I don't know if it's just me, but I've never had a problem reading your handwriting.
Sir, can we put the effective RMS and the maximum RMS?
Yeah.
yeah, what do you want me to write?
E effective equals 0.707.
Times E of max.
Yes.
E effective equals
0.707
E max.
times E.
And then the E max equals 1.414 times E effective.
And let's get a.
I feel like I can memorize that one and
Let's
realize
get I
that
effective
7
up
area
there.
code double. I'm not telling you.
it's the same thing.
It's the same thing, yeah.
Just substitute I for E. So I could actually get rid of the E's and just do effective equals times max.
That's what I was thinking, but I didn't want to.
Or you can do I/E effective.
Yeah.
An example.
Anything else? Yeah.
Can we get the 0 equals to reactive? I mean, react,
Yeah. 1 equals.
and then 1 equals to the resistive? Hey, he had said an NDA for that. Like a good ice cream recipe.
No,
Anything else?
What's the hypothetical best ice cream over?
we need to focus. If there's anything else that needs to go up there right now.
I know, and it's
I'll better start looking through your notes. Seriously.
Right here?
What about yours?
I've got a whole page of all the points.
On that one's like a BA, yeah.
Can you put these up there twice just in case?
How much?
I think it's just to distinguish the two, the difference maybe.
They give you that value, you know what they're referencing.
Last, yeah.
Oh, can you do this? Can you do like inductive Henry's frequency hertz inductive reactance ohms?
You have this much room right here.
I know. That's why I asked.
Dude, I'll write it. I'll put it real small.
I was trying to get something. Okay.
You want
See how your own 2 cents in, huh?
All right, just so you can say I'm not fair. Those are the answers to all of the test questions on the scan.
Way to go.
Sir, how much computing of stuff is on the test? Is there a fair amount, or
There is something.
is there more than like 2?
12 minutes.
Well,
It's
right.
enough that if you can't do one of these, you're going to fail the test.
Okay. Well, okay.
The test is just going to be 10 of those things we just did.